One of our another R&D activities is a landscape model where we're taking some of these parameters into an ecological simulation that will let us understand how our management activities are doing in our projects. So using the parameters that we've extracted from the data, try and create some relationships that let us understand how excuse me, I've lost my train of thought. So if we do a management activity at a project that changes the landscape, what will that do in terms of our critical habitats and things like that. So this is an example of our the parameters that we're looking at for this particular project. We have Barrier Islands situation where we're looking at the width, the distance to the dune peak, slope, elevation, and our zero contour. And we've looked at the literature to understand the relationships of that to different vegetation types. And so looking at these I guess it's a binomial relationship between all of these parameters with the different vegetation types. We can start to understand that if we change something about these parameters like the beach width by placing sediment on the beach, that we can understand how that changes the landscape. Another example is benthic habitat mapping out in West Maui, Hawaii. In this particular case, our engineers are interested in understanding where the sand resources are so that they can start to look at moving some of that sand onto the beaches for a regional sediment management project. They also want to understand where the coral reef resources are. So we were able to do some ground truth work out there and use our LiDAR and hyperspectral imagery to do a habitat map, and I have another slide that shows an example of this as well, or another view of that. And then also, using some of these same parameters, we're looking at developing a sea turtle nesting habitat model. We have a large area of the coastline that's been designated as critical habitat for one of our turtle species of interest. So we're looking at developing some decision support tools that help our engineers understand what sections of the coast may be more or less likely to be habitat for nesting for these turtles. We, I guess, presented all of those parameters we're extracting from the data to some turtle experts, and they told us which ones are the most likely to impact turtle species and turtle nesting. So we kind of focused on those, and what we're, I guess you have a little cartoon at the bottom that shows the ones that have the biggest impact. So artificial lighting, our beach width, beach slope, dune vegetation, and so extracting, actually the artificial lighting is pretty interesting when we're looking at building height and dune height to understand how much of the light on shore is actually getting onto the beach, because that's a critical parameter for the turtle species. But using those, we're able to develop a model that shows what areas are more suitable for turtle nesting than others. And I guess this is the final graphic that shows the probabilities for low, medium, and high nesting density for our turtles. And then I think this is my last example, but defining coastal regions. I guess in the Corps of Engineers we have a need to speed up our planning cycle so that if we're able to identify sections of coast that are similar, we can understand how management action that we did at one project may work at another, because they are very similar in terms of geomorphology or hydrodynamics. So we've developed a tool that lets us define coastal regions based on all of the parameters that I mentioned before. So showing these again: dune crest, beach width, the land use and land cover, and this is the results of that case study down in Florida. So using just a few of the parameters, we've identified sections of the coast that are colored the same, so they look similar geomorphologically and based on land use, and then you have more detail as you add more parameters in. So depending on what your application is, you can add more or less parameters to define those coastal regions. And then finally, this is a project that I've been working on, is looking at measuring and analyzing environmental condition and benefits. So taking the parameters that I showed in the early part of the presentation, using some relationships from the literature to actually start quantifying ecosystem goods and services. So if we start altering projects by adding or removing sediment, or rebuilding marshes, how can we quantify the benefits of those projects in terms of ecosystem goods and services? And that was my last slide.
We have a couple of minutes for questions for Jennifer. Who would like to ask Jennifer a question?
Yes?
Bill.
I want to start. Firstly, interesting presentation, Jennifer.
Thanks.
You put up a slide looking at characterizing submerged aquatic vegetation, and I didn't quite get from that what remote sensing tools you were using to collect that data. One or multiple?
Yes, and we were using bathymetric LiDAR and
For a second.
Oh,
If you could
repeat the
briefly
question.
repeat the question, because they wouldn't have heard any of that.
Okay. So the question for everybody on the phone was referencing the submerged aquatic vegetation, what technologies were we using? So in this particular case, we were using bathymetric LiDAR and hyperspectral imagery in a kind of a fusion paradigm. So using bottom reflectivity, depth, and water column turbidity extracted from the LiDAR data to constrain the radiometric radiative transfer equations of the hyperspectral imagery to produce these products. So we're looking at water leaving reflectance. That's from the LiDAR and the hyperspectral. With the LiDAR, it'll just be the 532 wavelength, and hyperspectral will have that at all of the wavelengths of the hyperspectral imagery. Water column attenuation is similar. The color dissolved organic matter absorption, chlorophyll concentration, and then finally active seafloor reflectance and spectral seafloor reflectance. And the product that we used to actually do the discrimination between eelgrass and macroalgae was the last one, which is the spectral seafloor reflectance.
Other questions for Jennifer? Paul.
Robert Storms. It's also related to detection of submerged vegetation, but oil in the near shore. It's an ongoing challenge. No really good technology. How about, have you done any work on that?
We, after the, I guess, BP oil spill in the Gulf, we flew some cross lines, and that was open. It wasn't coastal, it was open ocean. But we did fly some lines over that data, but we have unfortunately not had a chance to even look at it yet. So that's an ongoing effort to understand what we can actually determine about oil spill detection from this technology.
When you're collecting your imagery and you come up to the Canadian border, do you overlap at all, or do you just hit the border and turn around? Or?
Yeah, unfortunately, I guess we hit the border and turn around, and North Main is one of our gaps in data. Looking at Jamie apologetically. So no overlap there, but in the Great Lakes, that's certainly kind of what we do, hit the border and turn around. But if there are opportunities to collaborate and keep going around, I know back in 2002 we did a couple of areas on Lake Ontario on the Canadian side. So
you and Jafant need to talk. Jafant, you have a question?
I do. You were saying also that you monitor the inlets and the channel for navigation. I'm interested to know, do you have a plan of how systematically are you doing that, and how do you communicate? Are you responsible to release the information to the mariners for navigation, or do you transfer the information to NOAA?
That information is transferred to NOAA, who then releases the notices to mariners. Yeah.
But the other question was related to whether you got a systematically looking at the... Do
you review systematically, I don't know, on yearly basis, the inlets across the country, or how do you...
I guess, and you'll probably hear later from some of the bathy LiDAR talks, the main limitation of bathymetric LiDAR is water turbidity. So in the inlets where we can work, we do cover them on that 5-year cycle. So we go around the coast in about every 5 years. Now, there are other surveys done in the Corps of Engineers with single beam, multi-beam that also facilitate, that communication with NOAA too.
Okay, well, thanks very much,
Great.
Jennifer.
Thank you.
Appreciate your very interesting talk.
Thank you.